Evaluate the following limit. Whenever we have a limit, the first thing we want to do is try to use direct substitution. So here we have x is approaching 1. So if we try to plug in 1 here, we're going to end up with 1 squared minus 1 over 1 minus 1. And we end up getting 0 over 0, okay, which we can't have, right? We can't have 0 in the denominator of a fraction. This is also called an indeterminate form, which we'll talk about later. So when you use direct substitution and it fails you, where you end up with a 0 on the bottom, you want to try to use algebra if you can to simplify anything first. So here we can rewrite the numerator by factoring it using difference of squares. So we're going to have x plus 1 and x minus 1 over x minus 1. And then we can see that there's x minus 1 in the top and the bottom. They're going to cancel out. We're left with just the limit as x approaches 1 of x plus 1. Once we've simplified it, we can now use direct substitution again. So we'll try to plug in 1. 1 plus 1 is going to give us 2. Once you get an answer that works, right, then that's good and we're done. All right, so let's look at this top one here. So again, first step, use direct substitution. If I plug 0 in here, I'm going to end up getting a 0 in the bottom, which we can't have. So we are going to expand the top as much as we can. So we have the limit as h approaches 0. I'm going to FOIL this out here. So this is going to give us, I'll put this in parentheses, h squared plus 6h plus 9. And then we have that minus 9 over h. So we can see that the 9 is going to cancel out with the negative 9. So we have the limit as h approaches 0 of h squared plus 6h over h. And now we can use algebra to factor out a GCF from the numerator. So I'm going to pull out that h. So we have the limit as h approaches 0. H will come out. We have h plus 6. Denominator is h. We can then cancel out the h's. So we just have the limit as h approaches 0 of h plus 6. So now we can use direct substitution. We can plug in 0 and we end up getting 6. Okay, and then for this one, same thing. First step, direct substitution. I try to plug it in. We get a 0 on the bottom. So can we use algebra to kind of help us here? Well, whenever we see a radical, we want to try to rationalize it by multiplying by the conjugate. So the radical can be on the top or on the bottom. So what we're going to do is we're going to multiply this by the conjugate. And the conjugate is just whatever was the expression with the radical. We're just going to change the sign in the middle to the opposite sign. So it was minus 3, so we're going to make it plus 3. And we're going to do the same thing on the bottom. And the point of doing this is that it's going to help us cancel things out in the top, and that's going to help us in a little bit. Okay, so here we're going to FOIL. So if you FOIL the top together, we're going to have the square roots are going to cancel each other out. So let's write this like this, the limit as t approaches 0. So if I multiply those square roots, I'm just going to get t squared plus 9 out of the radical. Okay, if I multiply the square root times 3 and then negative 3 times the square root, they're going to cancel each other out. So now I just have negative 3 times 3, so negative 9. And then on the bottom, we have all this going on. So what I'm going to do is just smush it together. So I'm not really going to do anything. I'm just going to keep that t squared on the outside, and I'm just going to rewrite this. So they're just going to be kind of smushed together. So then we can see the numerator, the 9 minus 9 is going to cancel each other out. And we're left with this t squared on the top, but there's a t squared on the bottom. So we can actually divide those out. So remember, when you're dividing t squared and t squared, it doesn't just cancel out. It doesn't just go away. It's 1. So we want to make sure that we have that written down. So the numerator here is going to be 1. And then the denominator, we have that square root of t squared plus 9 plus 3. So now we can use direct substitution. I plug in 0. I'm going to get 1 over 0 squared, so 0 plus 9. Square root of 9 is 3. 3 plus 3 is 6. So the limit of this would be 1/6.